Hello everybody, welcome to the next GeoBoost video in the specialization in shallow geothermal energy. We are in the Submodule 1.5 and I will talk about the combination of groundwater heat pump systems and with other renewables and the integration of groundwater heat pumps in low temperature grids. We are in the part 1. I start with the combination of geothermal heat pumps with other renewable systems. This is also called as hybrid systems or combined systems or integrated systems. These combination leads at the end to improve energy efficiency, to reduce operational costs and increase system flexibility. What you see in the left side is you have a borehole heat exchanger in the underground, or also a borehole thermal energy storage, and you have photovoltaic on the roof. And you can actually combine this. Photovoltaic can produce electricity, you can transfer electricity to heat, and so on. So I will explain it in the next slide more in detail. So here you see that you have a combination of solar collectors and or photovoltaic. Photovoltaic, as I said before, can produce electricity, especially in summertime. And maybe in summertime you don't need all this electricity for your household. So you can transfer this electricity by the heat exchanger and the heat pump in heat, and this heat can be stored in the underground in the boreholes. This leads to the effect that the temperature in the underground is increasing, and increased temperature in the underground is favorable in winter times, because then the temperature difference between the underground temperature and the temperature what you need in the house is not so high. So this is very favorable for the heat pump, because then you need less energy for your heat pump. But you can also combine it with a solar collector, and the solar collector can actually link to the heat storage. So a buffer tank, for example, for domestic hot water. So the solar collector can heat up the domestic hot water. So it must not be done by the geothermal heat pump. So you can actually reduce the size of the geothermal heat pump a little bit. And this is just done for the base load, for the heating of the household, and not for the hot domestic water. So also the solar collector can be linked directly to the source temperature. And increases the source temperature a little bit, so that also the difference between the source temperature and the use temperature in the household is a little bit less. So you can save here also heat energy for the heat pump. These combinations are quite favorable, but of course you can have several combinations of groundwater source heat pumps. So with, of course, other groundwater source heat pumps, you can have a large one and a small one, and so on. You can also combine it, as you see it here in the picture, with air source heat pumps, so that the air source heat pumps actually operates just in where the temperature outside is not so cool, but in cooler times actually then the ground source heat pumps comes in. And as we said, with photovoltaic, solar, with biomass, and also with excess heat and waste heat. Also, we know hybrid systems with gas boilers, which we do not want to have actually, but of course it's existing. The systems operating can be in parallel, or you can also have it designed in a cascade, and it is for buildings and for grids, of course. And the integration of such geothermal heat pumps with other renewable technologies offers multiple benefits. So hybrid systems provide adaptation to variability in thermal demand and climate fluctuations. You can decrease the electrical consumption and optimize use the available energy, especially if you combine photovoltaic and ground source heat pump. And then, of course, it leads to long-term reductions in operational costs, because you need less primary energy. And also it can reduce the installation costs. For example, it can reduce the borehole length. Thank you for listening.